All right, students. So let me go with today's lesson. Today's lesson is going to be about the factors for weathering. All right, how can the weathering process be expedited? The word expedite means to quicken the process of. Launch, how do you think the varying temperature and moisture conditions affect the weathering of rock? All right, let's take a look at some pictures. First picture here on the left is a arid-like climate. The picture on the right shows a more humid climate, just by the presence of clouds and moisture and rain falling. Which diagram would expedite the weathering process? Well, the picture on the right will, because we need the component of water with weathering. All right, we lack water in the desert. More preserved things can happen in the desert. More weathering would happen here in this climate. Next, which diagram would expedite the weathering process? All right, so looking at these two, we have cold conditions with snow, warmer conditions here in the forest. All right, forest, we have organic activity, we have organic decay, we have a lot of moisture, a lot of rain. So this process here, the one on the right, would weather the fastest. There is weathering here too as well in the left picture, but the one on the left would probably be more of ice wedging. That's probably the only really type of weathering that can occur in the picture on the left. Let's get some notes down. Number one, climate. Temperature and moisture are factors for both physical and chemical weathering. All right, let me go a little bit into this here. Please copy down the table down below. Climate type, moisture content. Physical weathering, high moisture. Chemical weathering, high moisture too. Both need moisture. Temperature conditions. We have low for physical and high for chemical. Now the reason why it's low for chemical brings me to my last point on here, which says physical weathering is greatest when temperatures rise above and below the freezing point of water. Right? Fluctuates between the two. Ice wedging. All right, next point, we have talc and quartz. Please open up your reference table, go to page 16. These are two minerals. Please locate talc. Right? Talc is kind of halfway down, about halfway down. And find quartz. Quartz is almost all the way down on the page. If we're concerned with weathering of two different minerals, what we need to take a look at here is hardness. Talc has a hardness of 1, quartz has a hardness of 7. So talc is weak, quartz is strong. Talc will weather faster, and quartz will weather slower. So hardness plays a role here in the weathering process. Number 2, for your notes, composition. The weaker the minerals in a rock, the rate of weathering increases. We have Mohs scale of hardness on the right. We have talc as being 1, gypsum 2, calcite 3, fluorite 4, apatite 5, feldspar 6, quartz 7, topaz 8, corundum 9. Corundum is also known as sapphire and ruby. And then number 10 is a girl's best friend, which is a diamond. Let's continue. Here we have a picture of Alka-Seltzer tablets. Which Alka-Seltzer tablet would expedite the weathering process, or would be expedited in the weathering process? We have a whole tab here, and then we have halves, right? So we broke this in 2 equal pieces, almost equal pieces. Then we broke up this whole tablet into quarters, and then we broke up this into a fine powder. So you can try this experiment at home. If you compare the times of dissolving, because these will dissolve, it would be the fastest for the powder and slowest for the whole tab. Right? Because what you're doing is you're exposing new surfaces for weathering to occur. right? So when you broke this in half, you exposed two new surfaces. Here, you broke this in half, now you're exposing all new sides for weathering to occur. And here there's many facets, many faces that can be broken down, and it's faster because now they're even smaller pieces. All right, let's go into number 3, please. Surface area. As the surface of a rock becomes more exposed to the atmosphere, the rate of weathering increases. So we have a whole block that can get broken up into other pieces, and again, you're exposing new surfaces for weathering to occur. You break this apart even more, exposing even more surfaces. Break this up even more, exposing more surfaces. And then if you break this up into being like a fine powder, many flat surfaces, and much smaller than the original mass. Let's go into the last point. Here we have outside and the core of the batholith. Which picture would expedite the weathering process or be expedited within the weathering process? So the word core means the center of. Right, so we're looking at the center of this big granitic batholith. Now this batholith here is a famous batholith in Yosemite National Park called El Capitan. So the core is kind of down here near the center of this big granitic batholith. Now, the closer the rock masses are to the surface, the greater the weathering will occur, or the faster it weathers. So this rock sample here on the outside near the surface will weather much faster than the core of this big granitic batholith. The core of this big granitic batholith will probably be well preserved. As it is, water has a tough time getting to rocks as it is. All right, let's go to number 4, exposure. When rocks are exposed at the Earth's surface, the rate of weathering increases. And if you notice here, you have this big cliff, right? Or this long cliff. It's not really big. I mean, you could probably jump down and not get hurt. But look at the base of your cliff, right? You have a lot of these rock masses that are now weathered in their fragments or fragmental pieces at the base of the cliff. Exposed. Let's practice 2 questions here together. First question: if a rock was crushed into tiny pieces, how would that affect the rate of weathering? All right, ladies and gents, so pause it here, gather your thoughts, answer the question, and once you have an answer, hit the play button. If a rock is crushed into tiny pieces, that means many more parts of it are now exposed for weathering to occur. And you break it into smaller pieces, it will weather faster than the bigger piece. Best answer here is choice B. Number 2, in which climate would the chemical weathering of limestone occur most rapidly? All right, we'll pause it here, gather your answer, and once you have an answer, hit the play button to listen for the answer. Okay, so weathering needs humidity, right? So we can eliminate A and C. They both are dry conditions. For chemical weathering to occur most rapidly, we're looking at warm conditions. Warm conditions can hold more moisture, and that's good for chemical weathering to occur, especially limestone. All right, last part, I want to go over this with you. When Egypt was being excavated from the sand, many artifacts were found, including a piece of Cleopatra's Needle. It was decided that the artifact would be displayed in public in New York City so that millions of people could observe the beauty of its hieroglyphics. How do you think the limestone artifact was affected by this decision? All right, ladies and gents, please pause this, gather your thoughts, get an answer, and once you have an answer, hit the play button to hear me speak. Okay. So you're going from Egypt to New York City. Dry conditions, arid conditions, much more arid than New York City is. And this is limestone. Right? Limestone rock. Go to your reference table, go to page 7, and find the sedimentary rock called limestone. So look under rock name, find limestone, and go across until you hit the column that says composition. And you notice that the composition of that is calcite. Okay. Go to your reference table, continue on page 16. Go to page 16 and find the mineral that says calcite. Calcite special. Go across until you get to the distinguishing characteristics column. And under the distinguishing characteristics, you notice it says bubbles with acid. So it chemically weathers with acid. With any acid. And rain that falls is acid rain. Right? It's not falling down as battery acid rain. It's what we call a dilute acid. Dilute means it's a very weak acid. Water is 7 on the pH scale, right, which is neutral. Like 6.9 or 6.8 can be the pH of acid water. Very dilute. That can begin the weathering process. Chemically weather limestone. In this artifact from Egypt. In addition, New York City, during the wintertime, water can get into the pore spaces of this rock, and it can physically weather as well, in the form of ice wedging. So this ancient artifact is being chemically weathered as well as physically weathered. So is this a smart decision? It is not. Right? We want to make sure we put this into a museum, right? Keep it secured so that we have lack of rain and the lack of this moisture and lack of acid rain that will affect this. Put it into a museum, or maybe build or construct or erect a glass around it and like a dehumidifier so that we can take away the moisture and this artifact can get preserved. All right, ladies and gents, that is today's lesson. Please work on the questions for practice. Have a great day.